Hello. In this video, I'm going to try to simplify the concept of chi-square statistics. My name is Dr. Felix Ayodele Oyile. Let's get started. So, the first question is, what is the chi-square statistics or the chi-square test? The chi-square test is one of the statistical techniques that could be used to assess the significance of the association between two categorical variables, be it within human population or any kind of population whatsoever. And the idea is that it tries to compare observed data distribution and the expected distribution. The expected data distribution is like a model that we want to check if our observed data distribution actually aligns with. So the idea is to help researchers to understand whether the difference we are seeing between these two types of distributions is due to chance or it actually reflects an authentic relationship between the two variables. So the chi-square statistic has found relevance in the fields of behavioral science, marketing, health research, and what have you. And it is very important too in decision making. So let's look at it closely, what it actually tries to achieve. Again, we say it's a statistical method among other statistical methods, okay? And the idea is to help us determine if an observed distribution is as a result of chance. There are three basic types of chi-square statistics. Number one is the test of independence. Number two is the test of homogeneity. While number three is the test of goodness. Otherwise, we describe it as goodness of fit test. Good. Now, when do we use the chi-square statistics? Number one, when we are dealing with categorical variables. Categorical variables are variables that tries to divide a population or a data set into groups. We say they are categorical in nature, okay? Maybe you have the male group, the female group. Now, there's an important assumption that we must bear in mind when we use the chi-square statistics. Number one, the sample size must be generally more than 20. The statistics gives more valid results or more accurate results when we are dealing with a large sample size. If you apply it for a small sample, you may end up with an inaccurate conclusion. And number two, the expected frequency that we have in our distribution should at least be 5. So the expected frequency should at least be 5. Otherwise, whatever result we get from our chi-square statistics or test will not be considered statistically reliable. Good. Now, how do we conduct the chi-square test? Number one, you have to define the hypothesis. You must define the hypothesis you actually want to test. An hypothesis is like the initial statement or the claim a researcher put forth for which he decides to conduct a study, to investigate. So you must define the hypothesis. Number two, you create contingency table. And number three, you calculate the expected frequency. And number four, you apply the chi-square formula. We're going to look at this one after the other. Now let's have an example. Let's look at this illustration. Imagine, let's assume a researcher made a claim that there is an equal proportion of females and males in every society. That is a claim, and that is exactly what we describe as a hypothesis. Now, in a bid to verify this claim, it is expected that the researcher will conduct a study. Then he wants to check, maybe select a particular community, and then he wants to count, do a sensor of the number of male and the number of female in that community. Okay, so essentially, if this is actually true, we are going to have what we call the expected. And then we're going to compare that with what we actually observe on the field. So chi-square test tries to compare what we expect to get based on the claim we have made with what we got based on the data we got on the field. So let's see this example. Let's say we conducted a study in a community with a population of 200 people, and then we came up with our contingency table. This is an example of 2x2 contingency table. We have a column for the expected, another column for the observed. In a population of 200 people, you expect, if that claim is actually true, that there are equal proportion, or there's an equal proportion of male and female in every society, then you expect that for a community of 200, we should have 100 male and then 100 female. But let's say on conducting that particular study, we arrived at 95 male and 105 female. Now, what you will notice here is that there is a difference in the number of female in this community. Now, the next big question is this: which is the goal of chi-square test? This difference we have established, which is actually 5, is this difference statistically significant? The 5 we have gotten, is this statistically what? Significant. And don't also forget that there could be a difference, but that difference may not be statistically significant. The implication is that that difference could have been due to chance. In other words, if you go back to take a sample or you take a sensor of that same community, you may likely find something different. So that is the idea of statistical significance. So if you recall, I mentioned there are 3 types of chi-square tests: the test of independence, the test of homogeneity, and the goodness of fit test. Now, the example we have just looked at is an example of the goodness of fit test. I want you to visualize the blue color as our expected proportion. And then we go to the field, we took a sample, and then we came up with the red color. Now, the idea, we want to check if our data sets, the observed data set, fit into our expected model. That is where the phrase goodness of fit actually came from. How do they fit into each other? Goodness of fit test. So, in terms of interpreting the chi-square test, we can interpret it using 3 different yardsticks. Okay, number 1, the critical value; number 2, the p-value; and also the effect size. For the critical value, what we need to do is to compare our calculated chi-square statistics with that of the critical value in our chi-square distribution table. And that is going to be based on our degree of freedom and our significance level. We use these 2 pieces of information to determine where our critical value is, and then we compare it with our calculated chi-square value. Now, while the p-value, of course, conventionally, we make use of a p-value of anything less than 0.05 is considered what? Significant. And then we look at the effect size. The effect size speaks more about how practically significant our difference is beyond statistical significance. Now, what are the limitations of the chi-square test? Number one, it is not appropriate for small sample. And number three, for the test of independence, we must be careful of possible violation. We must be sure there is. Now, for the test of independence, the assumption that the two data sets are independent must not be violated. And number three, it is sensitive to sample size. Of course, we must use a considerable sample size, but when you make use of too large sample size, you can of course pick a significance that may not really indicate a valid association, or maybe a minor association may be spotted in such a scenario. Okay, so conclusively, what is the importance of the chi-square test statistics? I've mentioned that we use it to compare variables, categorical variable, and our goal is to examine if there's a relationship between these two variables, or otherwise there is an association. And again, in practical terms, it has found use in different fields of research, behavioral science, social science, research genetics, and even in qualitative research. Further reading can further shed light into these very important statistical tests. Now, this is the much we're going to take on this. Join me again on research and statistics. Bye for now.